Now we're going to move on to the examiner's favorite parts. Basically because they love to get questions that always include integration by parts. Now, integration by parts is also known as the reverse of the product rule. Why is that? Well, let me just show you why it is. Now, if you want to write the actual product rule, it's that duv by dx, where u and v are the two expressions being multiplied, that would give you the u prime v plus the v u prime, the v prime u. And then if I wanted to actually do by parts, if I wanted to make this one here, the subject of the formula is going to be uv prime equals to uv all prime minus u prime v. And if you want to write it in forms of dv dx and such, it's u into dv by dx equals to d into uv over dx minus v into du by dx. Now if I wanted to multiply by the integral, because you can do that to any formula, it's going to be u into dv by dx equals to d into uv over dx into dx again, and minus v du by dx into dx. What happens here is that the dx's will cancel out, and this will leave us with the formula for integration by parts, which is that if you have a u dv, this is actually equals to uv minus the integral of v du. And this is the general formula of integration by parts. Now that you know how integration by parts is the reverse of the product rule, you're probably wondering about what is integration by parts. Well, integration by parts is a method that we use when we have a product of two expressions, which is here uv, u and dv. Now the product, these two expressions, one can be easily differentiated, while the other one can be easily integrated, because here we're going to be differentiating one, which is the u, and we're going to be integrating the dv into v. Now then, after that, the aim of the integration by parts is to get the simpler integration, which is usually of one single expression, from the original complicated integration. So if we want to take examples in order to be able to apply all these, let us take ones. Here the example I have for you is find the integral of x sine x dx. Now when you get this, you can think, well, I can't do any trigonometric identity, although there's sine x. I can just simply divide them into two integrals. You're going to think, well, substitution, sine x will give cosine x and x will give 1, it's not the other, so none of the previous methods work. So what we're going to do is try integration by parts. We look at the two expressions we have and we think which is easier to differentiate. However, the first hint is try to always differentiate x, because it will go down to 1, and that just simplifies your life. So what we're going to say is that, okay, so if we want our u, that will be our x, and our du is actually going to equal to dx. And then if we want our other part, which is the dv, this will equal to sine x dx. And if we want to integrate that, we know that what leads to sine x is negative cosine x. Now if we want to write our general formula for integration by parts, we know that u into dv equals to uv minus v du. And then we write it out. So what we're going to write out is we're going to replace simply, we're going to say this is actually equals to u into v, which is in our case minus x cosine x minus x cosine x, and then we're going to subtract v du. V is negative cosine x, so this will become plus, and this will be cosine x, and our du is actually dx. and we know how to integrate cosine because we know that if we want to differentiate sine, it will give cosine, so this is actually sine. In other words, our answer is minus cosine x cosine x plus sine x. And never forget your plus c when you're done with integrating. And that will be your answer. It is fairly simple and easy how you base your answer on. Now I want to give you another example because this is pretty tricky, and as I said, it's not tricky, it's just that it comes really often and I really need you to perfect it. And let's try something with exponential functions and logarithmic functions. Here we have ln x dx. Now it's only seemingly one expression, but what is difficult is that we know that if we integrate 1 over x, we're going to get ln x. But we do not know what we integrate ln x to. It's one of the things I told you don't know, but you get with practice because you're going to think of it now. As we said, we know it's very easy that if we want to differentiate ln x, we're going to get 1 over x. So that's our first hint. If we let u equals to ln x, then we can so easily get du, which is 1 over x dx. Now that if we want to think of the dv, whatever we have left is the dv, which is here dx, and our v is going to be x. Now if we want to write the general formula again, which is u dv equals to uv minus v du, and we're going to replace here, so our uv is going to be x ln x, and this is going to be minus our v, which is x, du, which is 1 over x. So this is going to be x over x dx, which is 1 actually, and this is going to be x ln x minus x plus c. This integration is actually very important, and it comes really often, so you can actually memorize it. But in the exam, I'd rather you solve it out, but memorize it for shortcuts. With the integral of ln x is actually ln x minus x, and never forget your plus c. And that would be for integration by parts. Everything else is the same. You try to look for what is going to, if you look for two expressions or something that's difficult to integrate, you look for what is easier to differentiate and what is easier to integrate. Choose your variable, solve it out, and reach your answer easily and nicely. And that will be it.